Imagine a cosmic monster so powerful that not even light can escape its grasp. That's a black hole for you. At its core, a black hole is a region in space where gravity is so strong that nothing can escape. It's like a bottomless pit in the fabric of the universe. The gravity is so intense because a lot of matter is squeezed into a tiny space. Think of squeezing an entire star into a space smaller than a city. The edge of a black hole is called the event horizon. It's the point of no return. Once anything crosses this boundary, it's gone forever. Not even light, the fastest thing in the universe, can escape. Inside a black hole, our understanding of physics breaks down. We think there's a singularity at the center, a point where gravity becomes infinite. Black holes challenge our understanding of space, time, and the fundamental laws of nature. How does something as extreme as a black hole come into existence? It all starts with a star. But not just any star. We're talking about the big ones. Stars that are at least 20 times more massive than our sun. When a massive star runs out of fuel, it can no longer support its own weight. The core collapses in on itself. The outer layers are blown away in a spectacular explosion called a supernova. If it's massive enough, not even the forces between atoms can stop the collapse. Gravity takes over, crushing the remnants smaller and smaller. Eventually it becomes so dense that it punctures the fabric of space-time. That's when a black hole is born. Scientists think the largest black holes, the ones at the centers of galaxies, formed differently. Not all black holes are created equal. They come in different sizes with different origins. Let's start small and work our way up. The smallest are called stellar mass black holes. These form from the collapse of individual stars. They're typically about 10 to 100 times the mass of our sun. Next up are the intermediate mass black holes. These are the middle children of the black hole family. They might be the result of many stellar mass black holes merging, or they could form in dense star clusters. They range from about 100 to 100,000 solar masses. The heavyweights are the supermassive black holes. These cosmic giants lurk at the centers of most galaxies, including our own Milky Way. They can be millions or even billions of times more massive than the sun. How they got so big is one of the big questions in astronomy. Black holes don't just swallow things, they twist the very fabric of reality. Einstein's theory of general relativity tells us that massive objects warp space and time. Black holes are so massive that they create extreme distortions. It's like a bowling ball sitting on a trampoline but taken to the extreme. This warping has some wild effects. Time slows down near a black hole. If you watched a friend fall into one, they would appear to slow down as they got closer to the event horizon. From their perspective, time outside would speed up. If they could somehow survive and escape, they might find that years or even centuries had passed. Space gets twisted too. Light doesn't travel in straight lines near a black hole. It follows the curves in space-time. This can create some bizarre optical effects. In 2019, astronomers took the first ever picture of a black hole's shadow, showing light bending around it. Black holes are full of surprises. Here's one. They're not actually black. Physicist Stephen Hawking showed that black holes should emit a faint glow of radiation. It's called Hawking radiation. Over an incredibly long time, this radiation could cause a black hole to evaporate. But don't worry, for large black holes, this would take longer than the current age of the universe. Black holes also spin, sometimes incredibly fast. The fastest ones we've found spin at nearly half the speed of light. This spinning drags space-time around with it, like a spoon stirring honey. It's called frame dragging, and it can fling nearby objects around at incredible speeds. Lastly, black holes aren't always loners. We've found pairs of black holes orbiting each other. When they merge, they release gravitational waves, ripples in the fabric of space-time. We detected these waves for the first time in 2015. So why do we care about these cosmic vacuum cleaners? For one, they're nature's laboratories. They let us test physics in ways we never could on Earth. By studying black holes, we learn about gravity, space-time, and the fundamental laws of the universe. They're windows into extreme physics. Black holes also play a crucial role in shaping galaxies. The supermassive black holes at galactic centers influence how stars and gas move. They can trigger or shut down star formation. Understanding black holes helps us understand how galaxies evolve. It's part of the cosmic story of how we came to be. Studying black holes pushes technology forward. To observe them, we've had to develop incredibly sensitive instruments. These advances have applications beyond astronomy. The same tech that helps us see black holes could lead to better medical imaging or more efficient communications. Finally, black holes spark our imagination and challenge our understanding of reality.